In the world of cybersecurity, knowledge is power. Understanding the threats we face online is crucial to protecting ourselves. One such threat, often lurking in the shadows of websites we visit daily, is cross-site scripting, or XSS. Imagine a digital Trojan horse, silently infiltrating a trusted website. This malicious code, disguised as harmless script, waits to strike unsuspecting users. That, in essence, is the danger of XSS. XSS exploits vulnerabilities in websites to inject malicious scripts into web pages viewed by other users. These scripts can wreak havoc, stealing sensitive information like login credentials, hijacking user sessions, or even taking control of your computer. The consequences can be devastating, both for individuals and organizations. The good news is that XSS is a preventable threat. By understanding how these attacks work and adopting robust security measures, we can fortify our defenses and stay safe online. In the following sections, we'll delve deeper into the world of XSS, exploring its various forms, demonstrating a typical attack, and outlining essential defensive strategies. Cross-site scripting, often abbreviated as XSS, is a type of web security vulnerability that allows attackers to inject malicious code into websites. This malicious code, typically in the form of JavaScript, is then executed by unsuspecting users who visit the compromised website. Imagine visiting your favorite online store, unaware that a hacker has injected malicious code into the website's product review section. As you browse the reviews, the hidden script springs into action. It could be designed to steal your login credentials, redirect you to a malicious website, or even install malware on your computer. The danger of XSS lies in its ability to exploit the trust users place in websites. When your browser loads a web page, it assumes that all the code on that page is legitimate and safe to execute. XSS attacks take advantage of this trust by injecting malicious code that appears to be part of the website itself. The consequences of a successful XSS attack can be severe. Victims may experience financial losses, identity theft, data breaches, and more. XSS attacks come in various forms, each with its own level of sophistication and impact. Understanding the different types of XSS is crucial for developing effective defense strategies. Let's examine three main categories of XSS attacks. Stored XSS. This type of attack involves injecting malicious code directly into the website's database. For example, a hacker could submit a comment on a blog post that includes malicious JavaScript. When other users view the blog post, the malicious code is executed in their browsers, potentially compromising their accounts or devices. Reflected XSS. In reflected XSS attacks, the malicious code is reflected back to the user via the website. Imagine a search engine that displays your search terms in the results page. An attacker could craft a malicious URL containing JavaScript code. When you click on the link, the malicious code is sent back to the website and executed in your browser. DOM-based XSS. Unlike the previous two types, DOM-based XSS attacks manipulate the website's document object model, DOM, to inject and execute malicious code. The DOM represents the website's structure and content. Attackers exploit vulnerabilities in the website's client-side code to modify the DOM and inject malicious scripts. These scripts can then access sensitive information or perform actions on behalf of the user. Understanding the nuances of each XSS attack type is essential for developers and security professionals to implement appropriate security measures. Section 4. Anatomy of an attack, a simple XSS scenario. Let's visualize a simple XSS attack to understand how it unfolds in the real world. Imagine a website with a contact form. This form allows users to submit their name, email address, and a message. A hacker discovers that the website doesn't properly sanitize user input. They decide to inject malicious JavaScript code into the message field of the contact form. The malicious code is designed to steal the cookies of any user who views the message. When another user, let's say the website administrator, views the submitted message, the injected JavaScript code executes in their browser. The code silently sends the administrator's cookies to the attacker's server. With the stolen cookies, the attacker can now impersonate the administrator, gaining unauthorized access to the website and potentially sensitive data. This simple example illustrates the insidious nature of XSS attacks. They can exploit seemingly harmless features of websites to compromise users and steal valuable information. Section 5. Building your defenses, protecting against XSS. Protecting against XSS attacks requires a multifaceted approach, combining secure coding practices, input validation, and other security measures. Let's explore some essential tips for defending against XSS. First, sanitize input. One of the most effective ways to prevent XSS is to sanitize user input. This involves removing or escaping special characters that could be interpreted as code by the browser. By treating all user input as potentially malicious, developers can prevent XSS attacks from the outset. Second, use Content Security Policy, or CSP. CSP is a security mechanism that allows website owners to control the resources the browser is allowed to load. By implementing a strict CSP, websites can prevent the execution of inline scripts and restrict the loading of external scripts to trusted sources. Third, escape special characters. When displaying user-generated content, it's crucial to escape special characters like less than and greater than signs to prevent them from being interpreted as HTML tags. Escaping these characters ensures that they are displayed as plain text, rendering any embedded scripts harmless. Finally, validate input. Input validation involves checking user input against a set of predefined rules or constraints. This ensures that the input conforms to the expected format and prevents malicious code from being submitted. Regular expressions and data type validation are common techniques used for input validation. By implementing these defensive measures, developers can significantly reduce the risk of XSS vulnerabilities in their web applications. Section 6. The White Hats, Ethical Hacking and Responsible Disclosure. While hackers are often associated with malicious activities, there exists a community of ethical hackers who play a crucial role in cybersecurity. Ethical hackers use their skills to identify vulnerabilities in systems and applications before malicious actors can exploit them. They follow a strict code of ethics, obtaining permission from website owners before conducting security assessments. Responsible disclosure is a key principle of ethical hacking. When a vulnerability is discovered, ethical hackers report it to the affected organization through proper channels, allowing them to fix the issue before it's exploited. This collaborative approach helps make the internet a safer place for everyone. Ethical hacking and responsible disclosure are essential for strengthening cybersecurity defenses and building trust between security researchers and organizations. Section 7. Stay informed, stay safe. A call to action. In today's interconnected world, cybersecurity is everyone's responsibility. As we've seen, XSS attacks pose a significant threat to individuals and organizations alike. By understanding the nature of XSS, its various forms, and the importance of preventive measures, we can all contribute to a safer online environment. Stay informed about the latest cybersecurity threats and best practices. Share this knowledge with your friends, family, and colleagues. By working together, we can raise awareness and empower each other to navigate the digital world securely. Remember, knowledge is power, and in the fight against cybercrime, we are all on the same team.